Have you ever just wished your AI could do more than just, chat? Like actually do stuff for you out in the real world? Book a flight, manage your Trello board, you name it. Well, today, we're diving into a brand new method that's all about making that happen. Automatically connecting these super powerful AI models to the tools you and I use every single day.
But that begs the question, right? If these AIs are so smart, why is this so hard? Why can't it just connect to my Spotify or my Google Calendar? The real heart of the problem, and what this research just tackles head-on, is the incredible amount of manual, human effort it takes to teach an AI how to use every single one of these external tools. You see, for every tool, a developer has to literally sit down and write something called glue code. It is exactly what it sounds like. It's this custom, painstaking, manual job of sticking the AI's brain to the tool's functions. And this is a massive engineering bottleneck. It's slow, it's super repetitive, and honestly, it's holding back the true potential of what AI agents could be. Okay, so here's the game plan. We're going to start by really digging into this connection problem. Then we'll look at the brilliant design of a new solution called AutoMCP. We'll see it work its magic, check the results, figure out why it occasionally messes up, and then, most importantly, understand the new world this opens up for AI. So to really get why this new approach is such a big deal, we first have to look at what people were trying before, a standard that had a great idea, but a really big catch. That standard is called the Model Context Protocol, or MCP. It came from Anthropic, and the idea is fantastic. Think of it like a universal translator. Instead of hard-coding every connection, MCP lets an AI just ask a tool, "Hey, what can you do?" And the tool can hand back a menu of its skills. It's meant to be dynamic, it's meant to be flexible. It's a great idea, but, and this is a huge but, here's the catch. Even with this cool new protocol, developers still had to manually build that translator, the MCP server, for every single tool. They were right back to writing boring, repetitive code, which just completely defeated the whole point of making tool use easy and scalable in the first place. So naturally, this led some researchers to ask a really important question. What if we could just automate that? And this is where their solution, a tool they built called AutoMCP, enters the picture. Their plan was, frankly, brilliant. Instead of having a human write the translator code, they decided to build a compiler to do it for them. Now, if you're not a programmer, a compiler is just a tool that automatically translates code from one language to another. In this case, AutoMCP was designed to read a tool's public user manual, its API documentation, and just spit out a fully functional server that an AI could talk to instantly. So, how does this magic trick work? Well, it's a pretty straightforward process. First, AutoMCP just reads the API's official documentation, its blueprint. Then, and this is a big one, it automatically figures out all the tricky authentication and security stuff. After that, it generates all the server code, turning every function into a tool the AI can use. And finally, it just bundles it all up into a neat little package, ready to go. No human coding required. All right, that's the theory. It sounds great on paper. But let's see how this thing actually performs in the wild with a tool we all know, the project management app, Trello. So this is the goal, right? A totally seamless flow. It starts with a person making a simple request, it goes all the way to the Trello service itself, and sitting right in the middle, doing all the hard work, is the server that AutoMCP generated completely on its own. Let's walk through what's happening here. Okay, so watch this. A person just says, "Create a bug card." The AI, Claude, is smart enough to know that means it needs the Create Card tool. It calls the AutoMCP server. Now, the server does the boring but crucial work. It injects the secret API keys and makes the official call to Trello. Trello says, "Yep, got it, done." And Claude reports back to the human in plain English. That whole messy, manual glue code nightmare, it's just gone. It's all automatic. Now, that Trello example is slick for sure. But here's the million-dollar question. Does this actually work at scale? What happens when you throw dozens of different messy, real-world APIs at it? The first pass was, honestly, pretty amazing. Out of more than 1,000 different tool functions they tested across 50 different APIs, 76.5% of them worked perfectly, right out of the box, zero human intervention. That's a huge win to start with.
But what about that other 23.5%, the ones that failed? Did the automation finally hit a wall? Was this the limit? Well, what they found when they dug into those failures was not at all what you'd expect.
That was the final success rate. How? Well, the researchers made a few tiny little fixes. Not to their compiler, not to AutoMCP, no. They made tiny fixes to the original API documentation from the companies themselves. And the success rate rocketed up to 99.9%.
And getting this automation right is absolutely critical. Because as you can see here, interest in this whole idea, connecting AIs to tools using this protocol, is growing exponentially. As more and more people want to do this, a manual approach just becomes completely impossible. Automation like this isn't just a convenience, it's a necessity for the whole ecosystem to actually work.
So to really understand that incredible jump from a respectable 76% to a mind-blowing 99.9%, we have to look at what was actually breaking the automation in the first place.
The investigation found 5 main culprits. The biggest one by far, at 62% of all failures, was just incorrect or missing security info in the docs. You also see things like undocumented settings and broken web addresses. But here is the real kicker. Every single one of these failures was caused by a mistake in the public documentation. It wasn't a bug in AutoMCP. The tool was working perfectly. It was being fed bad instructions.
And when I say the fixes were simple, I mean they were really simple. Look at this example from GitLab's API. The documentation said a project ID was a number, an integer, but it was actually text, a string. Changing one single word in the documentation file fixed the entire problem. A typo. A typo was breaking the automation. And get this. Across all the tools that initially failed, the average fix only required changing about 19 lines in the documentation file. We are not talking about complex programming or rewriting code. We're talking about the equivalent of fixing a few typos in an instruction manual.
So, what's the big picture lesson here? What does all this actually mean for how we build software and AI from now on? It all boils down to this one powerful sentence from the paper. The problem, the bottleneck, it's no longer writing the code. We can automate that. The new bottleneck is the quality of the instructions we give the machine. The fastest way to get our tools ready for AI agents isn't hiring more coders to write glue code. It's just making sure our public blueprints, our API specs, are accurate. This completely flips the script on where we need to focus our energy. You know, manually having to click a subscribe button is exactly the kind of tedious task we should automate away. But until we get an API for that, you'll have to do it the old-fashioned way. So, to keep your own mental models automatically updated, go ahead and subscribe to VibeDoc. And drop a comment with the next complex topic you want us to compile into an explainer for you.